In this video, we're going to continue applications of solving inequalities. So in part C, we had created this inequality where this represented the amount of water in the truck at time t, and the person driving the truck wanted to know when that amount, for what values of t, would that be less than 1,300 gallons. So now let's look at part D. We are asked to solve the inequality from part C. We're asked to write the solution set in interval notation, graph the result, and we're also going to interpret our answer. And we'll round to 2 decimal places if necessary. So before we solve this, let's take a look at this inequality. So I'm going to write this. Let's write this here on the right and how we constructed it. So we didn't construct it in terms of t. We really constructed it in terms of the context of the problem. We said that we had 4,000 gallons of water, and then we subtracted off 528 gallons per minute times the number of minutes. So that's how we created this inequality. Okay. But let's think of how we might think of this in terms of t. Okay. So if we were going to instruct this in terms of the number of minutes, we take t, multiply it by 528, and then subtract that result from 4,000. Okay. So that subtracting the result from kind of reverses the order a little bit compared to how we usually construct them. So we could think of this as 4,000 plus negative 528t is less than 1,300. And then our construction story would make a little bit more sense in terms of how we were constructing before. So take t, multiply it by negative 528, and add 4,000 to that product, and the result is less than 1,300. Okay? And as an exercise, you should solve this inequality that way. I want us to work with the original because I want you to see different variations of how we can solve these. It's not really that different, but we're going to solve this using the properties of inequalities that we learned, and we're going to see something a little bit different happens. So notice, okay, the first thing we want to do is subtract 4,000. Just like here, we would subtract 4,000. That would be our last step in constructing this left-hand side in terms of t. So notice 4,000 and 528t, they're connected by subtraction, okay? And we don't write it, but this is really a positive 4,000, okay? And we need to subtract it, not multiply it or divide it, because of the way they're connected via subtraction, okay? But the 4,000 is positive. So I'm going to subtract 4,000 from both sides. And now on the left-hand side, I'm going to write the 0. I'm going to write the 0. 0 minus 528t is less than negative 2,700. Okay? And we said we usually don't write this 0 here. Okay? It's implied that it's a 0. But I wrote it here intentionally to show you this is 0 minus 528t. Okay? So we would really think of this as negative 528t is less than negative 2,700. Okay, so it's tempting to omit the subtraction sign, okay, because we're no longer subtracting. There's a 0 out front, and we usually drop it, okay, but we need to keep it and think of it now as adding the opposite of 528t. Okay, so notice how that connects to how we rewrote this equation using addition. Okay, so the moral of the story is, okay, when you have a subtraction symbol and you have added or subtracted and something with subtraction in front of it is left over, keep that as now the sign or the coefficient of that term. Okay, next step, we're going to divide by negative 528 on both sides. Okay, and now when we write our result, notice the left-hand side, the negative 528's cancel, so I have t. And remember, in this step, you need to reverse the inequality direction because we have divided by a negative. So make sure you do that in the exact step where you divide. Now, let's put this in the calculator. So a negative divided by a negative is positive, so I'm going to omit the signs just because in this calculator they're kind of a pain, but you could definitely include them on your calculator and you'll get a positive result. Rounding this to 2 decimal places, I have 5.11. Okay. So t is greater than 5.11. That's the solution set for our inequality. So now let's graph it. So it says to write an interval notation. I think it's easier to graph it first and then to transfer that into interval notation. So we have 0 to 10. This is 1, 2, 3, 4. 5 is right about here. I'm going to write that kind of low because we want 5.11. Now you don't need to find 5.11 exactly. Okay, you might want to note this is 5, this is 5.5. Okay, so 5.11 is a little bit bigger than 5, and it's definitely less than 5.5. Okay, and we're going to draw an open circle because it's a strict inequality. And when you do that, it kind of takes up some space. Okay, so you want to make sure you label it underneath. So I'm going to put the 0.11, and then we can see, even though it takes up a little space, it looks like it's touching 5. This circle is representing 5.11, which is our boundary value. Now the question is, are we moving to the right or to the left? Okay, so this says t is greater than 5.11. So numbers greater than 5.11 are to the right. Okay, if you still like to pick test values, which is always a good plan, and 0 is my favorite test value, if we replace t with 0, we can ask, is 0 greater than 5.11? And our answer is no. So we don't want the side with 0, we want the side not with 0, the other side. So now I'm going to draw the line and the arrow showing that this moves infinitely in the positive direction. Okay. So now that we have our graph, let's write our interval notation. Let's call it int not for short. Now remember, you start with your leftmost value. Our leftmost value is 5.11. Since it's an open circle, we're going to use a parenthesis. Then we put a comma, and there is no right boundary, so this goes to infinity. Okay, and infinity always gets a parenthesis. Okay, so we have one last thing to do, and that's interpret our answer. So what does this mean? So remember, we were trying to find the values of t, okay, so that the amount of water in the tank is less than 1,300 gallons. So you will say when t is greater than, and we'll use, that means strictly greater than, we're not going to write the equal to, when t is greater than 5.11 seconds, make sure you include your units so we know it's seconds and not minutes or hours. The amount of water looking here is less than 1,300 gallons. So you can really interpret this. If you looked at the first part that asked the question where we built this up, that will help also. But you can really interpret this by looking at the inequality itself, what the left-hand side represented, okay, what we solved for and why. So there's our t is greater than 5.11 seconds, and then the less than 1,300 gallons. Let's look at the next one. Now, in the context of this problem, it doesn't make sense for the amount of water in the truck to be less than 0. Okay? So that's some information. We'll talk about that in a second. So determine the values of t in your solution set for which W, the amount of water in the tank, is greater than or equal to 0. Then we're going to write this revised solution set in interval notation and graph the result. We'll round to 2 decimal places as needed. Okay? So let's look at this number line. And something I should have done and I didn't is this was representing time in minutes. Okay, so it's always good in a contextual problem. That E just disappeared. Now the S disappeared. Okay, now it's staying. So T was representing time in minutes, okay, and it's good to label that so you know what it's referring to. Okay, so we know from the beginning of the problem that at 0 time in seconds we had 4,000 gallons of water. And we actually found the values for 1 second, 2 seconds, 3 seconds. I don't remember them exactly, but remember they were going down. They were decreasing at 528 gallons per second. What we found is the value, or the approximate value because we rounded, 5.11 seconds is where the amount of water is 1,300 gallons. So the water is draining, and if we keep going on in time, eventually there's going to be no water in the truck. Okay, so it really doesn't make sense to go to infinity or say our solution goes to infinity, because that would give us negative values for the amount of water in the truck. And we want to stop our solution set when the truck is out of water or the amount of water is 0. Okay, so this solution is for the general inequality here, okay, out of context, but in context we need to allow for this or constrain because of this. So let's find the values for which the amount of water is greater than or equal to 0. So, and remember we're finding values of t, so we're going to use this expression involving t. 4,000 minus 528t. We want to know when that's greater than or equal to 0. Okay. So I'm going to solve this one a little bit differently, just so you can see. I'm going to add 528t to both sides. Okay. And we usually don't do that, but there's no reason we can't. And the reason I want to is the right-hand side is 0. So, and also just to show you something new. So now we have 4,000 is greater than or equal to 528t. And now we can divide by 528. So let's do that on the calculator. 4,000 divided by 528, rounded to 2 decimal places, is 7.58. Okay. And remember, we can write this equivalently if you want your t on the left as t is less than or equal to 7.58 seconds. So at approximately 7.58 seconds, that's when the truck will be out of water. So now let's graph this. This is time in minutes. And now we want two things to be true. We want t to be strictly greater than 5.11 and t to be less than or equal to 7.58. So here's our 5.11 was about here, 1, 2, 3, 4, 5. Okay. And t less than or equal to 7.58, well here's 6, 7, and 7.58 is a little bit more than half, and I'm going to use a solid circle. Okay, so 5.11, 7.58, and the values that work for both of these is anything in between. Now if we want to write this as a bounded inequality, okay, we would want our t in the middle, Okay. T is greater than 5.11, and it's less than or equal to 7.58. In interval notation, you would write 5.11 with a parenthesis and 7.58 with a bracket.